Right, so let's have a look at the Junior Certificate Higher Level Maths Paper 2 for 2018. This is question 3 and 4. So question 3 here we'll do first. We have a solid cone which has radius 5 centimeters and height 12 centimeters. Its length here, L, we don't know yet. Use the theorem of Pythagoras to work out the value of L, the slant height of the cone. Okay, so let's have a look at that first. Now we have within the cone here, we have a right angle triangle here. So all we got to do is use Pythagoras' theorem to work out L. So I'll just draw the right angle triangle first. So we have this kind of situation here. This is our right angle triangle. We have 12 centimeters here and we have 5 centimeters along here. We've got to work out L. So we know that L squared then will give us 12 squared plus 5 squared, or L squared will give us 144 plus 25, or L squared is 169. That will just give us an L, a slant height then, of the square root of 169, which is 13 centimeters. And you may even have recognized this as a Pythagorean triple, 5, 12, 13. But anyway, our answer here is 13 centimeters, that's L. Next part of the question just asks us to work out the total surface area of the cone. Give your answer in centimeters squared, correct to the nearest, or correct one decimal place. So the total surface area of a cone, let me just write that down first. The total surface area of a cone is, it's going to be the area of the base, which is a circle, plus the area, the curved surface area, which is this area around here. So the area of the circle at the bottom is just pi r squared, and the area of the curved surface is pi or L. That's given in your maths tables, your log tables. So let's just leave pi as it is for the moment. We'll bring it in at the very end. Pi is pi, and r then is 5, so we've got to multiply that by 5 and we've got to square it. That's the area of the circle. We've got pi here times 5 again times L, we know now, is 13. So we just got to work all this out here. Here we've got 25 pi, 5 squared is 25, and here we've got 5 13s, which is 65 pi. Add those two together, you get 65, 75, 85, 90, 90 pi. And when we multiply 90 by pi to one decimal place, we get 282.7 centimeters squared. This is just to one decimal place. Okay, so that's our answer there. That's our total surface area of the cone. Okay, the next question, part C here, just asks us to have a look at the net of the cone. It's made up of two parts, a circle and a sector. These can be shown in the table below. So this is the circle at the bottom of the cone, and when you take the curved surface area and open it out, it looks like this. Complete the table by filling in each of the 4 missing measurements. Give each value in centimeters, correct one decimal place where necessary. Okay, so our circle here at the bottom, we want to know what the radius of this circle here is. Well, if you look at your cone, I actually have one here. This is a cone. If I just show you how the net works here, if I take this here, just move it over, you can see at the very bottom, well, they've flipped it upside down here, but you can see where the circle comes from. It's just the bottom of the cone. So this radius here for our circle is the same as the radius for our cone. So the radius of our for our cone was 5 centimeters. So the radius of our circle here is also 5 centimeters. The circumference of this circle here is just going to be given by the formula for circumference of a circle. So the circumference of a circle is just 2 pi r, 2 times pi times r, which is in this particular case 2 times pi, which you can get on your calculator, and r is 5. So it's 10 times pi, which is 31.4 centimeters to 1 decimal place. So that's our circumference. So it's 31.4 centimeters. Okay, so let's look at the curved surface area here. Now the curved surface area on our right here, again, if we go back and look at our net here. So again, remember we started with the cone that looks like this. We opened up the circle. Now if we cut down along here, cut down along this dotted line here, and open it out, you can see we get this sector here. Now this sector is part of a circle, if you like, where this is the center. And what we're asked in this particular question is find the radius of this sector. In other words, the distance from here to here. This is our radius of this particular sector. So what was that in our original cone? Well, if we have a look back again, you can see it's actually the slant height. From here up to here is the slant height of the cone. So if as we open it out, you can see it becomes, the slant height becomes the radius of this sector, the distance from here to here. So really, when we go back to our question here, the radius of this sector is actually just our slant height. And our slant height of the cone, we worked that out earlier, was 13. It was 13 centimeters. Now the length of the arc is from here around to here. So what is that in terms of our cone? Well, again, if we go back, just have a look here. So we're looking for this distance here now, our arc length from here to here. So let's have a look at what that was originally. Well, that was just the circumference of our circle. So our circle here fits nicely back in there. If we just bring it back again, you can see it's down here. So what we're actually looking for is the circumference of this circle here. You can see when it opens out that it just becomes the length of the arc. And there you go, you can see it there. So we just want the length of the arc here. Okay, so the length of our particular arc was 31.4. The length of our arc was 31.4. So that goes in here. And that's it really for question 3. Okay, so let's move on, have a look at question 4. Hagar takes part in a chess competition. In each game she can win, draw or lose. So there are 3 possibilities. In each game she plays, each of these 3 outcomes is equally likely. So she has a 1/3 chance of winning, a 1/3 chance of drawing, 1/3 chance of losing. Write down the probability that Hagar wins her first game. So the probability of a win in the first game is just 1/3, because each of these possibilities is equally likely. Okay, so second part then just asks us to fill out this table here. Now we have 2 games here. We have game number 1 and game number 2. So fill in the table to show the 9 possible outcomes of Hagar's first 2 games. 1 is already done. So here you can see she can lose the first game and she can win the second game. LW means she loses game 1 and wins game 2. So you just got to fill this out. So let's see, here she can win the first game and win the second game. Here she can win the first game, draw the second game. Here she can win and then lose, draw and win. Here she can draw both games. Here she can draw and then lose. This is done for us already. She can lose and then win. Here she can lose and draw, and then finally here she can lose, and then lose the second game, lose both games. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities over both of these games. 9 possible outcomes. Find the probability that Hagar wins game 1 and loses game 2. So 2 ways of looking at this. There are 9 possibilities. So she can win. What's the probability then that she wins game 1 and then loses game 2? So wins and then loses. Well, there's only one of those. There's only one possibility where she wins the first one, loses the second one. So that's 1 out of 9. Another way of looking at it would be she would need to win game 1, so the probability of winning game 1 is 1/3, and then means multiply. Losing game 2, so there's a probability that of 1/3 that she loses game 2. So if we multiply these two together, we also get 1/9. So the probability of winning and then losing is 1/9. Okay, so part 2, wins at least one of her first 2 games. Wins at least one of her first 2 games. So winning at least one. So let's see, how many of those are there? Well, here's one. Here she wins both, that's at least 1. Here she wins 1, that's at least 1. Here she wins 1, that's at least 1. So we have 3 so far. Here she draws and then wins, so again that's winning at least 1, so that's 4 so far. Here she only draws both, so she doesn't win either. Here she doesn't win either of them. Here she doesn't win either. Here she doesn't win either. But here on the bottom left she does win 1. So there are 5 possibilities. This one, this one, this one. That's 3, 4, and then this one down here. So there are 5 possibilities out of 9. So the probability of winning at least one of the 2 games is just 5 out of 9. Okay, next one then. Hagar plays 3 games in the competition. Work out the total number of different possible outcomes for her 3 games. Well, if she just wins 1 game, there are 3 possibilities. If she just plays 1 game, there are 3 possibilities. If she plays another game, there are another 3 possibilities, so we multiply by 3. If she plays another game, there are another 3 possibilities. So there are actually 27 outcomes in total. If you look at that from the point of view of a tree diagram, now I may not be able to draw all of this because it'll get kind of fairly big, but if you take if you look at it like this, in the first game she can win, lose or draw. So this is the first game here. Now if she wins the first one, she's going to go on and play another game. So again she can win, lose or draw. Win, lose or draw here. If she loses the first game, goes on to play another game, she can win, lose or draw that game. Same here. If she draws the first game, the second game she can win, lose or draw it. So this is game number 2. So now she has 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities, 9 outcomes so far. Win, 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 lose, win, draw, lose, win, lose, 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 draw, draw, win, draw, lose, draw, draw. So there are 9 outcomes so far. But we're asked to look at 3 games. So if we look at the third game now, it's going to get a little bit cramped here, but if she wins the first one, wins the second one, again there are 3 possibilities. 1, 2, 3. Win, lose or draw. Win, lose, draw. Win, lose, draw, and so on. Win, lose, draw. And you can see here for each one of these there are 3 possibilities. So it's really 3 of these 9s, 3 9s. You're going to have 27 possibilities along here. So the total number of possible outcomes for her 3 games is 27. Okay, so let's have a look at part 2 then. It says work out the probability that she doesn't win any of her 3 games. So now she's not going to win any of these 3 games. Okay, so let's have a look at that. So the probability of her winning is 1/3. So that means the probability that she's not going to win, is going to be 2/3. In other words, this is the probability that she's either going to lose or draw. It's going to be 2/3. So we want her to, she doesn't win any of her 3 games, so she has to not win 3 games. So the probability of her not winning the first game is 2/3, and not winning the second game is also 2/3, and not winning the third game is also 2/3. So the and here, whenever we say and here, we're going to multiply in probability. So multiply these 3 together, you get 2 2s, 4 2 4s, 8. Here you get 3 3s, 9, 3 9s, 27. So this is equal to the probability. This is equal to the probability that she doesn't win any of her 3 games. And that's it. This is our answer here. Okay, so that's it for both of these questions.